Okay, let's start again so that we can walk out of here at 6 o'clock because you all have lives and things to do. And we will have squeezed just about 3 hours of HPSG into your brains by then. This is going to be a relatively radical departure from the lofty heights that Emily was having you sail in for the last hour and a half, 2 hours. I'd like to talk about a grammar implementation. There are a number of groups around the world, lots of very clever people, who have been working on implementations of this HPSG framework, often with mutually incompatible hypotheses or views. Largely compatible, but there's Sturm und Drang in the discussions about how best to do implementation of HPSG. And I am going to cheerfully not tell you about any of those other people, except somewhat in passing. Simply take advantage of the microphone and say, I'm going to tell you what I've been doing over my summer vacation for the last 25 years.
Boy, summer vacation, really long.
Yeah, long summer vacation. I do want to remind you about these desiderata for the linguistic theory you saw in the first half. We are interested in general principles, in formal descriptive devices that can make predictions which are falsifiable. That is, we can test for grammaticality. We can ask native speakers whether something is a grammatical string or has the right meaning. We can check. This linguistic theory ought to have cross-linguistic validity, and we would also like simplicity, that is, generalizations. The underlying theme of those discussions, or the descriptions of using the type hierarchy and using lexical rules and trying to have feature structures with inherited appropriate attributes, that was all quietly, but rather noisily, an attempt at capturing generalizations and keeping the description of that language as simple as possible. As a grammar engineer, that's really important because otherwise one just goes crazy. So simplicity is important, but there are a number of deities that I have to make sacrifices to every day as I do grammar development. I'm interested in coverage, in accuracy, in this encoding of principles, that notion of generalization. I'm also terrified but faced with the problem of ambiguity. Language is massively ambiguous. You will never imagine, if you try to do this kind of work, how much ambiguity lurks there in the language. And I'm interested in that high-level requirement that Emily described of reversibility, of neutrality, indifference to the direction that one is working it in processing. So I want this very same grammar to be able to work both for starting from a string of words of English and producing a meaning representation, or going the other direction, generating strings of English that correspond to an input semantic representation, a meaning representation. So these are the issues that have to be balanced every time I make a move in trying to add or change something in the grammar. It can be a wrestling match. There are two other things which are really just about engineering that have almost nothing to say about the theory itself. All those first 5 are a direct tug of war between the engineering requirements and the theory, and there are places where we, in doing engineering, have pushed back upstream and said, the theory has to change or be adapted or be limited or be stretched in this way because we learned things in the process of engineering. Not that many great insights came out of engineering, I have to admit, but some. For these last two, for efficiency in processing and for maintenance and extensibility, Ivan Sog would just yawn whenever I complained about how his theory was causing me a certain kind of trouble. This meeting ended well. I did show up. I'm here.
Sorry about that.
But are you not logged in?
I am, but it's the 40 minutes thing that is.
We just started ours again, so you'll have to do that. We'll keep going?
I think you should keep going.
I'll keep going. You work out what you have to do. Do a machine what you need to do.
Okay.
So I'm interested, desperately interested, in whether it's going to take 50 minutes or 1,000 years to finish parsing a particular sentence using the model of the grammar that I've implemented. It's not very exciting. Sitting there twiddling my thumbs, waiting, even a few seconds is a really long time. If I just had a great idea, I've changed an analysis, I want to see if I broke something. If it takes me a few seconds to go through a single sentence, and I need to look at a few thousand sentences to see whether that change had the right good effect and not the wrong bad effects, then I'm going to be rather impatient if the processing cost is terrible. So efficiency always matters. In fact, it's the thing that ties me up most of the time. And there was that point about maintenance and extensibility. I hinted at this. I've been at this task with colleagues like Emily for about 24 years now, not quite 25, a quarter of a century. And I'm still working on the very same grammar. Some of us don't have much of an imagination or much of a life. We keep on working on the same old thing. So this grammar continues to get somewhat larger. I cover more sentences of English, more phenomena in English. I don't do all of them. Yes?
I don't know how to get to where you have the link stored, so I can't get your computer on, sorry.
Oh, I can do that. I go to my secret email account. It's my only email account. And I click on your link. And let me do a few things.
Right.
Do that. It's all right, I'm sure you'll all be entertained doing that. I do stop the camera, share the screen, because I'm a nice guy.
And you reviewed it over there?
And now can I go?
Yes.
There you go, yes.
Okay.
Thank you.
Good. Technology has been served. See, we're always enslaved
Yeah.
to our technology. Okay, so let me get